How can you, any ideas about part one there?
You have to differentiate it.
How would you do that?
Um, Not really sure.
Uh, this is just normal. Uh, let me change it. So instead of the phi of z, I'm going to write it as the f of x,
Mhm.
and I'm going to use x. So 1 over root 2 pi e to the minus a half x squared. So how could you differentiate that?
Um, the e to the minus half x squared would differentiate to minus half x squared e to the power of minus half x squared.
Okay, so that's e to the x squared, and so g dash of x uh, uh, so I suppose if you put in the minus a half, was it?
Yeah.
So the derivative of that will be minus x, was it? E to the minus a half x squared.
Wouldn't it be minus a half x squared? Why would it be just minus x when you bring it down?
What is the derivative of minus a half x squared?
Oh, okay. Do you have to do the derivative?
It's
Oh, minus x, yeah.
it's the derivative of the function inside the function. So if you have a
Oh,
half x
okay.
squared, then the derivative of that will be 2 times minus a half x squared.
hmm
And so using that, how can I get?
It shouldn't be x squared, it's just x. The derivative of minus half x squared.
Let's see. We subtract 1 from the power. Well, let's see. So the derivative of
It should
uh,
just be minus x, not minus x squared.
so I'm gonna use my calculator to check. The reason why I'm thinking it is because the derivative of e to the x is still e to the x.
hmm
Let's see. So what are we doing the derivative of here? E to the, so shift. So this is the derivative. Are you using the graphical one, are you? Do you know how to find it on the graphical?
Yeah, yeah.
Okay.
It's the same.
So minus a half uh, e shift long. So e to the power. Why there's no minus a half at the front? Sorry, e to the minus 1 over 2 alpha right bracket x squared. Is that it?
hmm
And let's say when x is 3, um, we get. Oh, sorry. So I'm using this one down here. Okay, so we get this answer minus 0.0333 whatever. Now let us. So what are we saying the answer is? Let's just delete that derivative thing. So we said the answer for this one, the derivative of that is minus. I was thinking it is. Oh, we both said x there. Minus x e to the minus a half x squared. And I need to replace this x with 3. And it should give the same number if it is the same. Why did that? That should be a 2. E, so 3. Yep, same number.
Mm-hmm.
It's because the derivative of e to the x is still e to the x. Perhaps for this one, yeah, that should be a 1. And I was just kind of comparing it to that. Maybe that's not the best comparison. Yeah, so you can sub a value in to check if it works. Okay, and so what is the derivative of the f of x?
Mm-hmm. So it would be minus x over root 2 pi. E to the minus half x squared.
Half x squared, that's it.
And then you have to solve that equals 0.
So that is equal to 0. And you could use a calculator. Technically, it's a... Oh. We could try to use the calculator.
How?
Just put it in. So minus...
Like the whole thing?
Yeah, why not? Not that. So minus alpha x over... No. I'm going to close bracket first. Oh, I just have to start again. Yeah, whole thing. Minus x over square root 2 pi shift e to the power minus 1 over 2 alpha x squared, and we said it's equal to 0.
Yeah.
And so we don't need to put it in if it's equal to 0 because that's the default, but we'll put it in anyway. Shift solve. Let's try lucky number 7. Come on, calculator. So this one's saying continue, meaning it didn't get an exact, or sorry, it didn't get a fully as accurate as it can answer.
Mm-hmm.
So we just press equals again.
How do you do this on my calculator?
Be very similar. Hang on, let's get an answer here first. And so this number at the bottom keeps getting closer to 0, like 10 to the minus 80. So your one will be solve n. Oh, it went towards 0. That's not helpful. I'll try your one. Or perhaps... Yeah, well, it's x times some e to the x squared. So on your one, it is run matrix, or we could use solver, whichever. If you do run matrix, maths, is it maths? Let me try again. Option calc. Yes, solve n. And then you just put it in there.
Solve n, okay. It's saying minus 28.
Minus 28?
Yeah, I don't know. It's literally saying like minus 28.7, minus 28.6, minus 28.5, minus 28.4. So,
It's giving you...
and then positive 28.4, positive 28.5, positive 28.6. 28.7,
Hold on.
8.8. It's doing something weird.
Why is it that? We want square root of 2 shift pi shift. Where's e on this one? Oh yeah, e to the minus half x squared, and this whole thing is equal to 0. Shift equals 0, and then we press equal to solve it, is it?
Yeah.
Sure. See, that's very unusual. Very, very unusual. Usually it just gives you one solution. Let's try to think about this then. This is basically x times some other x.
Mm-hmm.
And so something times something gives us 0. What do we know about these?
One of them has to be 0.
Yes.
Equal to 0. Sorry.
So either this one is 0 or this one is 0. Any idea about the first one?
If x was 0, then that whole thing would just be 0. I think.
Yeah, so x has to be 0. Something
Yeah.
divided by, yeah. Or, how about this one? How do we solve this?
You'd have to do...
Oh, sorry. This is what we needed when z equals 0.
Oh.
So this one, you could ln both sides, but ln of 0.
Oh.
Ln 0. Yes, you can't, it doesn't reach 0. And so that's it. So x equals 0, or in this case, z equals 0.
Okay.
Oh, why did they make me do that? Okay, there's no other turning points. Yep. True.
Yeah. Non-stationary points of inflection. Points of inflection is when the second derivative is equal to 0. Did I get that right?
The gradient should also be 0. No other turn.
Yeah, but it's non-stationary. So the gradient wouldn't be 0.
A point of inflection is when the gradient is 0, isn't it?
No.
What is it? What is it?
Not always. It's when the second derivative is equal to 0, I think.
Okay. Second derivative it is.
So then you have to find the second derivative, which is... Okay. So it would just be minus x squared over 2 pi over square root of 2 pi. Wait, no, x squared, positive x squared.
Basically, you have one x function times another x function.
Yeah.
So I believe it's going to be chain rule.
Mm-hmm. Oh, okay. So... But wouldn't minus x over root 2 pi just differentiate to minus 1 over root 2 pi?
Yeah.
Okay. And the other one would be minus x e to the power minus half x squared. So then...
Okay. Yeah. And so what is it then?
That would give you... minus x e to the power of minus half x squared over root 2 pi. Oh wait, no, it would be positive x e minus half. Yeah. I think that's right. And then we need to make that equal to 0.
Plus... hold on. No. So the first one, the derivative of this is minus 1 over root 2 pi. The derivative of this one,
minus x e to the power of minus half x squared.
x squared, and the chain rule is u v dash plus v u dash. So u times v dash, v times u dash.
So uv dash is x squared e to the power of minus half x squared over root 2 pi. And then vu dash is e to the power of minus half x squared over minus 2 root pi. Minus 2 pi, sorry.
Yes, and so wherever you put the minus, that's it. So that'll just be a minus. And what is next?
Equal to 0. But they have the same denominator, so you can just combine them.
Yes. What divided by 2 pi gives you 0?
0.
Therefore, what do you know about this top once you combine it?
It's equal to 0.
Yeah, and so that might help a bit.
Yeah, you can just write directly minus e minus 0. So that means you can make them equal. You could do x squared e to the power of minus half x squared is equal to e to the power of minus half x squared.
What would you do after that?
You could divide by e to the power of minus half x squared.
The reason why you don't do that is because if you divide by x, you lose that x answer. So those x's turn into 1. How did you solve your very first quadratics?
Factorize.
Do it.
So just factorize out e minus to the power of minus half x squared. And then you get x squared minus 1 is equal to 0. So then x squared is equal to 1. Or x squared is equal to 0. Yeah.
No.
Why would it be x squared is equal to 1, the second solution?
That's the first solution.
Oh, yeah. Right.
Okay.
The second one would be e to the minus half x squared is equal to 0. So that means x would equal 0. Wait, no. X wouldn't equal 0. No solutions.
However, it's
that means x is equal to plus minus root 1.
What's the square root of 1?
Just 1, yeah.
Yes, and I believe that's what we were asked to show.
Yeah.
And I'm using x just because that's what you're more used to. Mark the maximum point and the points of inflection on a sketch of the...
Let's just draw it, basically.
Yeah, so then you would draw it, and seeing that as how you've done all of that, I would sub in 1 and minus 1.
Yeah.
And so obviously when you sub in 1, it's easy enough. Minus 1 also easy enough. And so you give exact values. And you could also verify it with your calculator. Any questions there?
No.
Okay, why did they do these questions to us?
These are like the hardest ones.
Yeah, they're not too bad. That one there I thought was a bit much, but anyway. How about this one? Any ideas with this?
So you have to find the equation of the tangent.
Yep.
So you have to differentiate y equals tan 2x, which I don't know how to do.
So have do you have the
Oh, it's
formula here?
changeable, isn't it?
What is the derivative of tan x?
I don't remember.
Do you have the formula or anything?
I don't think we get given that, but we might. Oh, we do. Okay. Tan kx is k sec squared kx differentiated. So that would be 2 sec squared 2x to differentiate that.
2x. Okay. What is next?
So then you substitute x is equal to pi over 8.
Yep. What is it?
2.
How do you do sec squared in your calculator?
1 over cos.
Yeah.
So 2 times 1 cos. How do you do cos squared on the calculator?
Cos squared is short for, well, just a way of writing
Oh, it's 2
everything
pi over
squared.
8 squared. Right.
No. So put the whole thing in a bracket.
Oh, okay.
And the whole thing is squared.
That's 4. It's equal to 4, apparently. So then we do, you know what the gradient is. So then you have to find the y coordinate for x equals pi over 8. So you just do tan 2 times pi over 8, which is 1. So since you know it's 1, then you can just do y. You can substitute 1 and then substitute pi over 8 to find c. To find, like, that.
Okay.
So
And y was 1, was it?
yeah. Minus 0.57
What did you sub in?
pi over 8.
To find c, is it?
Yeah.
What did you sub it into?
Into y equals mx plus c.
So was it y is 1?
1 minus 4 times pi over 8.
Oh, sorry, silly me. I'm thinking of pi. Okay. And so it was, what was it, sorry?
Minus 0.571.
Let's do it 5 sig fig.
57079.
Okay. So So that's C.
Mm-hmm. Now that you know the equation of the tangent, which is y is equal to 4x minus 0.57079, then you can find the y-intercept. Well, you know what the y-intercept is. You can find the x-intercept.
Okay.
Then you can find the coordinates, and then you have to find the area. This question is so long.
Okay, go for it. Or if you think you've got an idea for it now, was it just?
Yeah, I know how to do it.
Okay.
I think it's just getting started with these really hard questions
Yeah.
because I just like read them and then I get scared.
It's. I think the worst is when you don't know like what you're even really been asked to do. Let's see. So, okay, how do you start this one?
For y equals cos, write an expression as a limit. I don't even understand the first part.
What, by first principles?
No, I know, like the first question, 11i. Like for y equals cos x plus h, write an expression for dy by dx as a limit. Would it just be cos x plus h minus cos x over h?
Yes. So that's
Okay.
not a question. That's just step one.
Okay.
Yeah. So if you know how to do this thing, then eventually.
Yeah, I think I know.
Yeah.
I know how to do first principles, but I haven't done it with like cos.
Want to do it now?
Do you get given small angle approximation? Oh, you do.
This isn't small angle approximation now.
No, but it says in the third part.
Oh, okay. Want to do this or?
Yeah.
Okay. How would you start?
So cos x plus h minus cos x over h.
Hold on. Prove. You can't just skip into the middle.
Oh, it's the first part though.
Using the following steps, write an expression. Oh, okay, I suppose. So, sorry, go on. Cos
x plus h minus cos x in brackets. It doesn't have to be, but over h. I use the compound angle expression to expand. Well, you get given those as well. I didn't even know.
Okay.
So that would give you cos x cos h minus sine x sine h. Use your answer to 2 and the small to rewrite your expression. Okay. Small angle approximation time. So cos theta is 1 minus half theta squared. So you do 1 minus half x squared times.
Which one is the small angle?
How do you know? Oh, x. Just x, right?
Just h. H is the small, very small change.
Oh, okay. But how do you know that it's h?
Well, not really, actually. Let's see. So cos x could just be anything, but the cos of x plus h. So no, it's h.
Sine h and cos h in the question.
H is definitely the small one. Well, where does it say it?
In part 3, it says use the answer to 2 and the small angle for sine h and cos h.
Yeah. H is a very small number.
Yeah. 1 minus half h squared.
Minus half
h squared.
Okay.
Minus sine x. And then h, just h, because sine theta is equal to theta.
Okay.
Minus cos x over h. How do you simplify that even more? I suppose you could factorize out cos x. No, yeah.
Yeah. Maybe we should have done that in the beginning, but okay. So go on.
So cos x in brackets 1 minus half h squared minus 1
Yeah.
minus 1 minus sine x h. So you could just cancel out both the ones.
Yep. What do you do next?
Find the limit as h tends to 0. So then you would just have, since you have cos x times minus half h squared, that would just equal 0. And sine xh would also equal 0. So
And you'd
every
also divide by 0?
yeah, so everything would just equal 0.
Dividing through by 0. Let me rewrite this now. This here, another way of writing this is minus a half h squared cos x minus sine xh over h. Notice anything?
No, they both have h
Yep,
that you could factorize out.
sure.
So if you take out h, you would have minus half h cos x minus sine x. Oh, okay. That makes sense. And then you could cancel out the h
Yeah,
from the top and the bottom. So then you have minus half h cos x minus sine x, which means you're just left with minus sine x because that whole thing will be equal to 0.
yes. So as x tends towards infinity, is it? H tends towards 0. And therefore what we're left with is dy by dx is equal to, this is times by 0.
Yeah.
And so just minus sine x.
X.
And so basically just do it by first principles, and they just helped you a bit. Any question there?
No, I know first principles. I revised it because I always forget it.
If you don't know how to do this, I would just do it yourself without these steps.
But you get the formula in the booklet, so it's okay
Like,
for first principles.
you're gonna need that formula anyway. You were pretty good for starting it, I think. Yeah, I think
Yeah,
you'll be
I
okay with
copied
it.
it from the book.
I think you'll be alright. So it's you could practice them, but it's basically so we
I
wanted.
just like forget how to do them, but like I know once I like get started, like I know how to do it.
So it's always, let's say y equals cos x. Let's do tan x. Let's do it the start of it. So y equals tan x. What would be the next bit?
You'd have tan x plus h
Yeah.
minus tan x.
Not just tan x plus h. So those are, so that's like tan x, and this
Yeah,
is a very small change.
yeah.
How did you find gradient in year 8?
Change in y over change in x.
Yeah.
Oh yeah, and then you have to do this, and you have So then you have.
So let's say for the first
Oh,
equation.
you just do tan x plus h minus tan x over x minus x plus h minus x.
Yes. So this one, x plus h, and that's
Tan x plus h.
Yeah. And that's where the
Yeah, you just replace x by x plus h basically. Like second one.
Yes. And so y2 minus y1 over x2, wait, x2 minus x1, and then you just go from there. Yeah, it comes from changing y over changing x. Okay, how about this one?
normal is parallel to the line. So if it's parallel to that line, then the gradient would be the same. So the gradient of the normal would be minus 1/4.
Minus a quarter.
Yeah.
Okay.
That means the gradient of the tangent is 4. So you just have to find where dy by dx is equal to 4. So you have to differentiate that. So 3x would just differentiate to 3.
Sure.
And then cos x would differentiate to minus sine x. So you'd have 3 plus 2 sine x.
Yeah.
Is equal to 4.
Let me think about this.
Sure, if that's right.
Fine. Yeah, that's fine. That's equal to 4.
So 2 sine x is equal to 1. And sine x is equal to half.
Hang on. Yep.
So x is equal to pi over 6.
Yep.
And then you just substitute to find y. So 3 times pi over 6. Minus 0.161, apparently.
Okay. And or we could always leave it as, what is cos pi over 6?
Cos pi over 6. Root 3 over 2.
Root 3 over 2 times 2 is root 3. And so an exact answer would be a half pi minus root 3.
Mm-hmm.
I believe. And those are our coordinates.
Yeah.
And part 2.
Tangent to the curve. So we already know the gradient of the tangent is 4. So you could, and since you know a point, you can find what c is. So you can just do half pi minus root 3 is equal to 4 times pi over 6 plus c. So c is minus 2.255.
So you could put this into your calculator and check that. They wanted the exact value.
Okay, so you could just leave it like that.
Yeah, and you might be able to simplify it. A half pi minus 4 over 6 pi.
That would give you minus pi over 6 minus root 3.
Yeah.
Yeah, so then you have y is equal to 4x minus pi over 6 minus root 3. Then oh wait, you don't do anything. It meets the y-axis. You already know that's the y-intercept minus pi over 6 minus root 3.
Mm-hmm.
And then O is the origin.
Mm-hmm.
How would you find... Oh, you have to do that thing you do in vectors where you do square root pi over 6 squared plus root 3 squared? Do you have to do that?
You're thinking of like Pythagoras or something, is it?
You know how you do it in like vectors to find the magnitude?
I don't know anything about vectors. Vector magnitude, yeah. They're just doing, that's just fancy Pythagoras, I believe. A visual aid will help. There's C. What is the distance?
Oh, the distance is just pi root 6 minus root 3.
Done. Yep.
Oh, okay.
Any questions about that one?
No, that one's pretty easy.
Okay. That was the last one I had. Let's see.
Questions.
Let's see. So these are different ones.
Mm-hmm.
Okay, question 9. How do we do it?
Oh, I think I can do question 9. It's just like the really hard ones that I can't really do.
10, 11?
Yeah.
Which one?
10, because I think that's implicit differentiation. I'm still not really sure how to do that.
You're not sure it's the easiest thing in the world. Okay, try it.
So x squared would just be 2x.
Yeah.
Plus 2 dy by dx.
No. 2y. And then stick a dy by dx after it.
Okay. Plus y dy by dx.
What is this?
1. Oh, product rule.
Yep.
So y dy by dx plus.
Hold on. U is x. V is y.
Mm-hmm.
U dash.
1. U dash is 1. And then that's y dy by dx. Yes?
If this is 1, then this must also be 1.
And then dy by dx. Oh, so you differentiate the y like it's an x, but then you just put dy by dx.
Exactly.
Oh, that's so easy.
I agree.
So then you just have y plus dy by dxx. Yeah. Okay. Now you have to minus 2x and minus y.
Yeah.
And then you have to factorize out dy by dx.
Yes. And so you're good for the rest of that?
And then you have to solve it, right? How would you do that? You have to solve equal to 0. dy by dx is equal to 0.
Okay. So let's see. So when we factorize it, dy by dx.
It should give you, 2y plus x.
X minus y. And so dy by dx is equal to?
Minus 2x minus y over 2y plus x.
2y plus x. And we have to do stationary points?
Yeah, equals to 0. So if you bring the denominator like up to the other side, then you would just have minus 2x minus y is equal to 0. But how would you solve that?
That's a simultaneous equation, but we've only got one equation. We need a second one. Can we get a second one? Yeah, we kind of have a second one up here.
Mm-hmm. But there's no x, y in the...
There's no x, y. What if I wrote this as that?
Yeah, you could.
And then?
Not really sure.
Y is minus 2x?
Oh, you can just substitute.
Mm-hmm.
Oh, but then you have minus 4x is equal to 0.
Sub
It's
it.
equal to 0.
This is simultaneous equations. This up here is equation 1. This is the same equation as itself.
Yeah. But like if you write that minus 2x is equal to y, then you can just substitute. So then, oh wait, no, that would just give you 0. Never mind. Okay. So you'd have x squared plus 4x squared plus minus 2x squared, not plus, yeah, is equal to 3. So minus x squared, 3x squared is equal to 3. So x squared is equal to 1. And x is equal to plus minus root 1. And x is equal to 0.
What is the square root of 1?
1.
Why is x equal to 0?
Because in the second equation, wouldn't x be equal to 0?
Why is that?
Because if you substitute minus 2x, then you would get minus 2x plus 2x. Wait, no, you would just get 0 equals 0. Not, okay, never mind.
Yeah, it's simultaneous equations. This is, you can't, if you sub an equation into itself, obviously, yeah.
Yeah.
Minus 2x equals minus 2x.
And you could just substitute 1 and minus 1 into the equation to find the y coordinate.
Yeah. Go on, what is it?
Gives you, but you don't know what y is, so how would you do? Oh, you do know, okay. So y is equal to minus 2 or plus 2.
Yes. Plus or minus 2. And I'm sure if you subbed it up into this up here, you'd get the same thing.
Yeah.
Any questions there?
Yeah.
Well, we got most of it. Let's see. So we didn't get to these two. A curve has this equation by using the product rule. Find this.
I think I can do that one.
Yeah, so that is implicit differentiation.
Yeah.
Yep.
The product rule.
And then this one.
Like I understand how to do it. You just differentiate y as normal, but then you just stick a dy by dx in front of it.
Yep. And actually, this one is also implicit, is it?
Yeah.
Yeah, because it's got y, and you have to find. You have to differentiate it. Yeah. So just implicit differentiation.
Okay.
Yeah. Well done. How was that for you, Amogha?
Hard.
Great. Anything in particular you want to do next time?
Mechanics.
Which bit?
Probably like the forces and like motion part of it.
Forces and motion.
Okay, on that, and variable acceleration is pretty easy, so it's just that one.
Year 1, year 2?
Just year 1. We don't need to know year 2 for the mock, so.
Okay. Any questions for me in general?
No.
All right, well done, Amogha. You did great. I look forward to chatting again next week.
Mm-hmm.
Have a good week. Goodbye.
Thank you.